Hello students, welcome to Edubbey Global Solution. In our mathematics class again, we are going to be looking at another topic which is cumulative frequency. And we have our interactive content here that will serve as a guide for this class. Okay, so let's start with cumulative. What is cumulative frequency? Okay, calculating the cumulative frequency is done by adding up the frequencies that are distributed over the class interval. So when you are calculating cumulative frequency, what we just do with that is we add up our frequency in a given class interval. Okay, so cumulative frequency diagram is useful for locating the median of a large data. And what is median? That is the mean to do value when you have a large set of information. Okay, so set and data set. Okay, and when establishing the consistency of the result of a data set. So we make use of what? Cumulative frequency. Okay, and look, let's have an illustration of how we can actually plot cumulative frequency. So the duration of a battery brand is recorded and the result is shown below. So look at this. This is the interval. We have this to be the duration to be the class interval, that is from time 0 minutes or to 5 minutes, from 5 minutes to 10 minutes, and it goes on to where we have 35 minutes and as well. So we have the frequency from to be 3, 5, 8, 10, 12, 7, and 5. And for us to get the cumulative frequency, what do we need to do? What we just need to do is what? We add up our frequency. And how do we go about that? So let's quickly see how we can add up. So what we do is see the first one. You know, there's no value before this frequency. So the first one stands as 3. Now the next one, you are picking 3 plus 5. That is this value plus this value. That is 3 plus 5. That gives 8. That's the next value. So to get the next cumulative frequency, you are bringing 8 here plus 8 that we have here. So we have 8 plus 8. And that gives 16. So if we want to get the next one, we are bringing 16 plus 10, that gives 26. 26 plus 12 gives 38. 38 plus 7 gives 45. And 45 plus 5 will give 50. Now, one thing about cumulative frequency is this. By the time you add up your frequency, the summation of this frequency is 50. So the last value of the cumulative frequency must tally with the total numbers of the frequency that we have been given. So if that is not there, there's a mistake somewhere. Okay, so we can now plot with this. So we are using the cumulative frequency against what? Against the duration. When we have 5, the cumulative frequency is 3, so we have our 3 here. When we have our cumulative frequency to be 8, okay, we have the time frame to be what? To be 10. So we have it here. So when we have the cumulative frequency to be 16, we have the time frame also to be 16. So we have it like this. When we have the cumulative frequency to be 26, we have time to be 20. So we have it under 20. So we have 26 and so on and so forth. So with that, we can easily identify our median. And how do we calculate median of any given value? Just find half of the total number, that is half of your n. So if our n here is what? Our n is 50, then we just find 50 divided by 2, and that will give us what? That's 25. So we can easily get the median from this place, and we have it to be what? That's we have 25. So by the time we trace, we have 25, and it's on 19 for the durations of that battery branch. So that gives us the median. Now let's look at quartile and interquartile range. Okay, cumulative frequency axis can be represented as well in terms of percentile. So when you're talking about a percentile scale divides the cumulative frequency scales divides it into hundreds. You know, percentage means like we're talking about percent, 100. Okay, so median, be the what? Median is what? Median is a middle value. So median is what we call the 58th percentage. Okay, then the 25th percentage is known as the upper quartile, and 75% is known as what? As the lower quartile. So the differences between the upper quartile and the lower quartile is what we refer to as what? Interquartile range. Now, when you're talking about quartile, we are talking about division of observation into 4 divine interval based on the value of the data that is being given. So when you're talking about quartile, that means that you are dividing your data set into 4 different different interval, and this is based on the value of data that is being given to us. So let's check our arrangement and let's see. Okay, so 75 pay. Oh, we have trying. Let's retry. Okay, so we have percentile to be this. Okay, so these are supposed to be our middle value. Okay, after we are done with our middle value, okay, 25% should be what? Should be the upper quartile. 75 is the upper and 25 should be the lower quartile. Okay, let's check now. Yes, we are right. Okay, now we are looking at the these activities. Let's study what we have here. So we have to calculate the lower quartile, the upper quartile for A, and the lower quartile for B. Then we are calculating the upper quartile for B and the lower quartile for type B as well. So we have this graph here, and we are going to be calculating the lower quartile, the upper quartile for type A. This is for type A and this is for type B. Okay, so for type A, how do you calculate lower quartile? We call lower quartile to be what? We call it Q1. And the formula for that is what? Half 1/4 of n, that is where n is the total numbers of the given data set. Okay, then we have Q2. Q2 to be what? That is the middle quartile. Okay, we have it to be that is 2/4 multiplied by n. Okay, and we have upper quartile to be, the upper quartile is Q3, and that is 3/4 multiplied by our n. So if you look at what we have here, the data set, we don't have this middle value. What we are just calculating is we are calculating the upper quartile and the lower quartile. So but we are going to be calculating everything together. So the total number of the frequency that we have here is what? 50. So for this one, it's going to be 1/4 multiplied by 50. And by the time we have that to be 12.5. Okay, for this one, it's going to be 2/4 multiplied by 50. That is 2 times 50, this is 100. 100 divided by 4 will give us what? Will give us 25. And Q3, that is what? 3/4 multiplied by 50. Okay, if you have that, that is what? 150 divided by 4, that is 37.5. So we can sketch now, look at it, 37.5, we trace it down, that is the Q3, this is Q3. For the middle quartile, that is we have that to be what? We have that to be 25. Okay, that is Q2. Q2 is 25. And if you look at it, this is Q1, which is the lower quartile, which is Q1. So the same thing applies. This is Q1, this is Q2, and we have this to be Q3. And we have identified that based on what we have here. So if we want to get the interquartile formula is we're calculating, we are dividing Q3, okay, minus Q1. So from here now, what is Q3? Q3 is what? We are using, considering the middle value here and the lower quartile. So for this one, we have 25, okay, minus what? Minus 13. We are using the density. 25 minus 13, that will give us 12. As we look at under this, we have the first one is base 25. We have 25 here, okay, minus what? Minus 13. This is the point here for Q1 minus Q3. And for the next one, the type B battery, this is the point here, 15, and we have 21 here. So it's going to be what? The type 2B is going to be 21 minus 15 and that is 6 Okay, now let's look at the next class activity that we have here, which is what? Which is okay, which is box and whiskered plot. A box and whiskered plot is defined as a graphical method of displaying variation in a set of data. So we have an example of how it looks like. The box and whiskered plot is in this form, where our minimum value start at this lower quartile, as made mention, which is what? Q1, the median, which is Q2, and upper quartile, which is 3, and the maximum value, that is the highest value of that given information. So when considering two sets of data, box and whiskered plots are an efficient way of comparing them. Okay, now let's look at this first question here. We have this given set of information. The height ranges from 50 less than a meter. I think that should be represented in meter. Okay, we have it to be m is what? Mass per gram. So less than or equals to 100, and that's how the range goes until when we have the structure from till 21, that is the frequency from the 43 to 21. So all we need to do here is what? We have to calculate the cumulative frequency. So I'm going to be doing that here. We call cumulative frequency CF. Okay. So the first point, you see, there's no value before it, so we have this to be 43. Now for the next one, it's going to be 43 plus 31, 43 plus 31, and that is going to give us 74. Now the next one is going to be 74 plus what? Plus 25. 74 plus 25, that's going to give us 99. And the last one is going to be what? 99 plus 21, that's going to give us 120. Remember that the cumulative frequency must tally with what? The normal frequency. So we have 120. This takes us to the end of our class. I want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.